I will never figure out how YouTube works, but I think we're going live. I hope we're going live. I got some kind of picture. It's going to be option to end the stream, so I'm going to work on the assumption that this is live. You can see my beautiful back. So what we have here is me having the wrong thing on the screen. That's what. There we go. What we have here is a couple of these cuties. So this is an Audioengine 2. This is a slave speaker. These are some PC speakers that were rather popular a few years ago, coming around 10 years by now. Gosh, time flies. And they're obviously starting to fail, as most cheapish speakers do. I think these were like a bit over €100 when they were new, perhaps a bit more. They're obviously targeted towards the fancy white Apple demographic. Are we really live? Is this web a viewer? Let's hope so. I got my hands on these because I found them at work, and there was a sticker on them saying trash, changed power amplifier, does not work, still quiet, and they were going to be binned. So I brought them home, and I've been spending a lot more time than they're worth trying to figure out just exactly what's wrong with them, and I think we're starting to get somewhere. Oh, here we have someone in the chat. Hello there, Fluffy Floof. Thank you for confirming that things are working. And you can see what's up. We've got some small speakers we're working on. There's a close-up for you. Audioengine 2s. About 10 years old. Right, so I've been spending a lot of time on these, trying to figure out what's wrong. I've got the PCB out. You just rip it out of the power amplifier module with a bunch of screws. It's pretty straightforward. You have to cut the glue. The previous tech had already done that for me, and I've been just going mad at this. So you can see the previous tech had swapped out a bunch of capacitors here. They'd redone a bunch of solder joints, and they've changed out to a power amplifier IC. It's just a linear thing, no class D and V's, nice and low noise. It's a TD87265, and not a bad little amplifier module. I quite like it. There used to be a bunch of small electrolytics here which were leaking all over. I swapped those out. It hasn't fixed it at all. The entire thing has been coated in this terrible, terrible black conductive glue, which is very, very common with these small computer speakery type things and subwoofers and such. And I think that might be the culprit as to why this has failed. So let's have a bit of a closer look at the PCB, and I'll explain why I think that is, and we'll try to confirm the failure mode by actually reassembling it. So the entire board basically was covered by the black goo, and this glue turns into, it just seems to turn into water and go conductive. So there's a bunch of corrosion everywhere on this, and I've cleaned it up. I've resoldered a bunch of stuff. This entire section I redid with all the little surface mount electrolytic caps there being replaced. I think we have a date on this thing somewhere. It's 2010. I've also resoldered a bunch of resistors, a bunch of diodes. I've checked all the diodes, all the ceramics. Nothing shorted, nothing's terrible. This thing generally looks to be in very good shape. But the keen-eyed among you might be noticing that we've got a hole in the PCB where there's supposed to be something. Now that would be the combined power switch and a volume control module. So this is one of those little clicky volume knobs that you turn the entire thing on and adjust the volume, and nothing weird there. So it's got a switch module on the back and a stereo potentiometer in the front. Very simple. So this was mounted, let's see, like so. soldered in, just corner soldered with a pads there on one side actually, and they'd stuck a bunch of this black goo on there to firmly made it in place. It's good that they have mechanical mains, but I think that has turned into an Achilles heel here. Craig Nearing is in the chat. Hello there, Craig. Happy 2020 to you. In a few hours anyway. So, the symptom this amplifier module has had, aside from just not turning on, is that there's a bunch of voltage missing. So the way this TDA 7265 works is we have a pin, I'll point it out for you. It would be this one. That's the muting / standby pin, and that's when this thing is on, this is basically tied to the positive rail, and if you take it to a voltage that's lower than the positive rail, as in you tie it towards ground, or you drop it below the positive rail at all really, the chip first goes into muting and then into standby. And that pin is switched by this little tiny, no that's not it, this little tiny surface mounted transistor, which I at first expected. It's fine, and that in turn is controlled pretty much straight from the switch in the potentiometer. And the symptom I've been seeing in this amplifier module is that there's just not been any voltage on the standby pin of the amplifier IC. So it's been stuck in power down mode, and as such there's of course no sound coming through. And I've been troubleshooting to hell. We have, you can see my replacement Zener diode here. This is a 5.6 volt Zener diode. I thought that was failed. It was not. Swapped it out just in case. And we've also replaced a resistor feeding the entire power on circuit. This guy here is a 47K. Thought that was failed, but I was just measuring poorly. So the way this power on circuit is built is you have a positive rail right here feeding to this 47K resistor, and it snakes its way across to the power switch here, and you can these pins here, these are for the power switch in the potentiometer. So when you have these speakers turned on like so, there's continuity between those two pins. So that by turning them on, you essentially connect the positive rail through this 47K resistor, through the switch, and through onwards to this trace, which snakes its way all the way over here, and I think it goes into, is it this capacitor? Let me double check that. Let's see. It goes to, yes, it goes to this capacitor right here. This guy. And that one's referenced to ground on the negative lead. So when you turn the speakers on, you are supposed to charge this capacitor up rather slowly through a 47K resistor, and that never happens. Now, how on earth can a circuit this simple? It's literally positive supply, resistor, trace, power switch, capacitor. How can that possibly fail? There's nothing there to go wrong. The power switch works fine, the resistor has been replaced, the capacitor has been replaced, but there will be no voltage. Well, we are dealing with a reasonably high impedance circuit. Since we're feeding everything through a 47K resistor, it doesn't take a lot to actually kill that. And the symptom I was seeing prior to getting this thing dismounted was when the power was off, the potentiometer turned way to the bottom, so it clicks and turns off. We would have high impedance on this feeding resistor. There would be just nothing there. It would be unloaded, everything would be fine, and we had voltage. But the moment we turned this on, there would be 300 ohms to ground here. And if you do have a resistive divider with 47k on one side and 300 ohms on the other, that's just going to turn into bloody well nothing. So there's something wrong with the other side of the power switch. And there's just basically nothing there on the other side of the power switch to cause a short. We've literally just got this diode feeding the transistor there, and that's all the stuff that's on the other side of the diode, on the power switch, and those components I've tested are fine. But when I do that, the short changes. And I think if we measure, while we have the switch disconnected right now, I think we're going to find that the 300 ohms I was seeing is no longer there. I'm sorry if this is just a rambly technical description of a problem rather than some actual troubleshooting. I've been working on this. I wasn't intending to actually document any of it, but I figured this is probably a common issue, might as well at least put it out there. So we're in ohms mode. So the issue was one of these two connectors, which go to the power switch, was 300 ohms to ground at all times, regardless of whether or not the power switch was on. So we will find ground, which is, give me a second, there is ground available on the top layer. Yeah, this is where one of the power capacitors is supposed to be. So that's ground. We are on the positive side, this is the negative side. A capacitor, it's a dual split supply amplifier. So if we measure one side of a power switch, 48, 50k, that's high impedance, that's completely fine. If we measure the other side of the power switch, 2 mega ohms, that's completely fine. When I started out, this was 300 ohms. Not 2 mega ohms. So I have a sneaking suspicion that, let's see here, that what has caused this entire issue is the conductive glue sucking into the PCB. We're looking at where the potentiometer is mounting to the board. I think this area here, this was completely covered with the black conductive glue, and that's because they just basically dipped the lower end of the potentiometer into the glue and just shoved it into the board. And we can see I've scratched this quite vigorously. We still have a bunch of crap in there that we need to get rid of. You can see that's not a clean board edge at all. That's rather nasty looking. Jeez, this camera is a bit underexposed, isn't it? Light is maxed. Hang on. Let me see if I can fix that. Technical difficulties. Configure video. Is that what I want to change? No. I think that's going to make it slightly brighter. Perhaps ever so slightly. Oh well. Probes going everywhere. So, right. Man, I'm not well set up. I have my stupid microphone in the completely wrong place. Anyway, so I'm reckoning if we just give this a very thorough scrapey cleanie, you can see the glue just coming off with glass fiber particles there. If we really clean this up properly, it's gonna turn out fine. And I think actually if we were to just put the potentiometer back right now, just having barely cleaned this, these speakers are actually going to work. Now keep in mind I have verified that they work by just bypassing the entire power on circuit. Oh, there's a solder pad completely covered in gunk there. That hasn't even been soldered. Ugh. I have verified that the speakers do work. Oh, this has done so hard. By bypassing the power on circuit. Ugh. This is so bad. So they will play audio. They just will not turn on. I was considering just leaving them as always being on, because when do you really need to turn this kind of thing off? But sadly, they make horrible pops when you plug them in if you just have them on forever, because the power on circuit also doubles as an anti-click circuit when on power on, due to the large capacitor that needs to be charged when you charge stuff through the 47k resistor I was showing you before. Really, putting the black glue on the edge of a board is just the worst idea, because since it turns into water, it's just going to suck straight into the PCB. I mean, the PCB is pretty porous. It's just glass fiber and plastic, basically. It's going to suck it up like a sponge, and then it's going to corrode from the inside. I don't want my face completely full of glass fiber black goo right here. It's going to be a real mess, so we'll wipe that off. You can really see how there's black goo everywhere, just soaking into the PCB. Oh, that's so bad. It's really gone everywhere. Before I started scratching, before I started the stream, it was even more obvious. There was like slight corrosion everywhere. I see Alphonse Jean has popped into the chat. Hello, Alphonse. Nice to see you. Happy New Year, man. We're all exciting people dealing with broken electronics on New Year's Eve, aren't we? But I suppose you do need to be slightly productive on a day like this if you're to get completely knackered as the clock strikes 12. Scratchy, scratch. Ugh, you can really see how there's moisture collecting under this. How fake is this stupid thing? We just peel that off. It's already evaporated, that wasn't a lot. Ah, crap, that went my blade. Alphonse Jean says, well, I don't celebrate New Year. Well, sir, that is your loss. The year will change regardless of whether you like it or not. I suppose lots of people are going to have more conservative celebrations than usual this year. At least I hope. Right, I think the rest of this isn't all that critical. We'll just give that a bit of an alcohol wipe, and is that the one I want? That's not the one I want. Is that the one I want? That's the one I want. We'll just give it a good scraping, and then we'll define it as good enough. A good cleaning, sorry. We still need to deal with the actual potentiometer module, because that's still a mess. Fluffy Floofy says, haha, might as well get drunk. Lots of people are probably going to get drunk alone in their flats this year, I would imagine. Ah, fuck, I forgot this side of the board. Yuck. Yuck. You. Disgusting. Absolutely abhorrent. I wonder how bad it is underneath this 3.5mm plug. It actually feels really hard and terrible and conductive, as it tends to get when it gets bad. So we might have to actually desolder the 3.5mm jack to prevent further corrosion in the future. Ah, this is very bad. It's completely hard. This jack has 1,000,000 pins. Ugh. I really don't want to disassemble this, but I don't think we have much choice. But we can verify that the speakers work before by dealing with the volume control module, which of course is completely covered in black gunk, because why wouldn't it be? Black conductive gunk makes everything better. It's completely hard and terrible. And this is going to cause like channel balance issues when it starts getting conductive across the potentiometer. It's going to attenuate the channels differently and cause crosstalk and all kinds of wonkiness. God, it's so bad. So bad. Come on. That's the worst of it. I want to do it down by the PCB as well. I don't care about the stuff on top of the potentiometer, let's say. It's not going to cause issues. It's not super hard around here. all soaked into a PCB. All soaked. Okay. Ethereal just showed up in the chat. Hello there. So I think this is probably good enough to not cause a bunch of problems in the future. We've gotten it off of the conductive part, so we'll just wipe it off with a alcohol Q-tip and go from there. We'll remount the potentiometer, power switch assembly, and see if the speakers actually turn on. I am quite convinced that they will, now that we've gotten rid of all the horrible black goo. Ugh. Just look at this stuff. I'm going to confirm that it's not actually soaked so far into the PCB we need to do reconstructive PCB surgery. Macomk says, ooh, a live stream. Hi. Hello there, Macomk. Nice to see you. I don't think I've seen you in the chat before. Welcome. So, let's just do a few quick probes on this, just to make sure we have no terrible leakage. 0.9 megaohms, 43K, 4 megaohms, 43K, megaohms, megaohms. And we have a bunch of stuff here as well. 42K. So we have, I think ground would be the middle one here, right in between the power switch pins. So that's what really matters, I suppose. Megohms. Megohms. Now there actually should be no connection at all there. Because the power switch is completely separate from the potentiometer, so we actually need to clean this up a bit better. Ugh, this is just so bad. Where did my stupid blade go? Oh, I don't care, let's take another one. Ah, the legendary K. Wills has shown up. Hey man, I've actually got a letter written for you, but I've yet to find my way to a mailbox to post it. Thank you for all the money, man. I really do appreciate it. Oh yeah, this is terrible. I'm not sure if this is actually going to fix the conduction issue, but we'll just work it a bit extra. So if you're just joining and not clued up on what's going on, we've got these cute Audioengine 2 speakers which will not turn on. Another tech had gone through them and replaced the power amplifier chip, a linear basic simple chip, and they didn't work, and since they're so cheap he just gave up on them, and I found them at work with a note on them saying scrap, and I just took them home because I'm far too stubborn to let something like this just die. And we are finding lots of black goo. I'm not going to redo the circuit reverse engineering I did in the beginning of a stream, but rest assured if we have reason to assume that it's nothing but the black goo causing these to fail. I'm going to resolder this just to try and get the black goo to sort of flow away a bit. Ugh. Bubbles due to moisture. That's so bad. Black goo will often sort of burn and break apart if you solder on it, and of course I've used too much solder there. Where's my hand? Where's my hand? That's cleaning it up slightly. I can scratch the last crap off, and it really does make it easier to get off once you sort of loosen it and melt the solder joints. I will solder that back together. That's going together much nicer now that there's not a bunch of black goo water on them. That's looking much better. And let's just do the power switch pins as well, just to be on the safe side. Author Thing says, have you figured out how to remove the huge computer monitor? If you're asking me, I'm assuming you are talking about like the big screen in front of me, which I might have mentioned I needed to move at one point, and we did figure that out. I had a friend come over and we just ripped all the computer parts out of it. Now it's just a touchscreen. I basically had to destroy this entire workshop to get it out though, because everything's baked in. It was an exciting night for sure. Where's my alcohol? There's my Q-tip. We'll wipe the worst crap off of this. Okay. I'm going to reapply some proper white glue that does not turn conductive once we get everything mounted together properly. Now I do wonder how deeply this is actually supposed to be. They probably have a jig in the factory to make that go smoothly. But we don't, we have to just wing it. I think it was sort of resting on the solder joints there. Oh, hang on, we can just like grab this and use it as a template. Okay, screw that, never mind, we'll just it'll be fine. It will be fine. It will be fine. I'll put a bit of tape on the back of that so it goes where I want it to. Matthew James says, hey, hey. Hello there, Matthew James. I hope you're having a lovely quarantined New Year's Eve with the rest of the world. So a bit of tape there to just keep it steady. That actually feels pretty good. And it should be doable under a microscope even. So most of the solder joints were on the top side. I don't remember what was soldered and what wasn't, so we'll just solder a bunch of stuff and hope that it'll be fine. I think most of this is just for mechanical rigidity anyway. It's going to be reasonably tricky to solder because it's a fairly large gap to jump. Oh no, it's actually completely fine. Smoking kills. Let's do that once we have one in each corner. Oh, and you definitely can't see that. I think they basically just disregarded their own design and didn't do a bunch of these from the factory. But we're doing a bunch of them. We're doing them all. This is looking so much nicer without the black goop. SDTTN says hello. Hello and Happy New Year, says DTTN. And as always, if you're just joining us, we are halfway through reassembling these Audioengine 2 speakers, the amplifier module at least, to see if we've managed to solve a problem where they would not turn on due to black glue turning conductive and just screwing everything up. I think everything was actually soldered on the bottom side and nothing on the top. So I'm not going to solder anything on the top either. And I definitely mounted that switch at a slight angle, which is oops. Author Thing says, I've been experimenting with Flex Seal as an electronics glue and conformal coating. Okay, I've never heard of that. I just use... Where's my usual? Casco Superfix. A gentleman's choice. So I definitely need to load up some public domain music, or this is going to turn horrible if we need to actually listen to these. Do I have something? Okay, I have some sort of actually licensed music. Okay, let's just hook this up and see what happens. I don't think there's going to be any smoke. We're not going to be that exciting. I have the power cord down here somewhere. So right now it's off. This thing is not well mounted, so it might short out, but I think we're fine. We're also missing a big capacitor, so we really cannot play loud at all. Or they're just going to start oscillating and falling apart. So we'll hook up a speaker. And we'll disregard the test signal for the time being. I just want to see if they turn on. I have a power meter over there where I can see if they start drawing more power when I turn them on. So let's... there's the power adapter turned on. Hey! I think they're working. They're drawing nothing, they're off now. And if we get the microphone really up here, they go pop buzz. They're super sensitive to being held. Don't like that at all. But I think if we feed some combat player music that I licensed years ago for no money, ka-ching, into this, it's gonna make some noise. Fingers crossed. And we can turn it off. Or can we turn it off? Yes, they're turned off. Now we really can't play them a lot because we are missing a decoupling capacitor and we are missing the heatsink, so that's all the testing we're going to get. But we have solved the issue. No explosions. The only fault these speakers had was the stupid annoying black glue of death right there. So if you have these, just clean, desolder this, clean this area off of a black goo. You probably want to do the entire board while you're at it, but if they're not turning on, this area is what you want to focus on. This entire circuit had no faults. The power amplifier had no faults. It was just black goo shorting out the power switch, because the power switch is coupled through a 47k resistor right there, which just cannot handle the amount of conduction that the black glue causes. Gah. Terrible, terrible, terrible. So now we just need to clean up the rest of this crap and reassemble everything. So this is where it gets boring, quiet and mechanical, and all the actual troubleshooting is over with. This is such a shame that they keep using this stuff. I don't know how many. Just imagine how many pairs of these speakers are going to end up just getting thrown away because they used bad glue. It's probably like 90% of them are going to be in a landfill in a few years when they just all fail. Unbelievable. It's also astonishing how all these small active speaker pairs, like power amplifiers, all look exactly the same. Like this just looks like a smaller version of the power amplifier in a Behringer. It looks like a smaller version of the amplifier module in those rockets that Dave on EV blog did the exact same operation on a few years ago. Like, geez. Do all of these come from the same factory or what? Ugh. The copper's just ripping off with the glue. We're also going to be swapping out all the capacitors while we're at it, because, yeah, there's a bunch of crappy ones I don't want to deal with. Yuck. Station Devoted says, Chinese will use anything as glue. Imagine what they use as lube. I would imagine fat from feral bats. Going along with the meme of the year. Get rid of you, there are traces under you. Stupid glue. Ah, fiddlesticks. We have all the glue underneath the 3.5mm connector still. That's really bad. I can't see anything because it's so dark, but that's the underside of the 3.5mm connector. It's just completely full of crap as well. That will cause issues. That's just no way around it. We need to get the 3.5mm plug off because it will just it will start conducting that, and if this can turn into 300 ohms of a power switch, it can turn into 300 ohms and by the 3.5mm connector as well, and that's going to short out any signal going into these. And that would be bad. Author Thing says Mackie M8 studio monitors had the same thing. Now, those sound expensive. The Rockets, at least, they're cheap as well. Mackies, though, you pay out of the arse for them. Come on. Melt. The solder of this pin is not cooperating. Okay, fireworks outside. Someone's being a bit premature. Oh, this is going to be so bad. Getting this thing off is going to be an absolute pain. So, to those who are just joining us, we have already fixed these speakers. We're just working on the fine details now. The problem was black conductive glue on the power switch right here. So, if you're tuning in just because you have a broken set of Audioengine 2s, you can safely just take them apart, clean the glue out, hope that it hasn't corroded everything to shit, and put them back together again. I think we can more or less just rip this off now. There's some solder splatter on one of the plastic holes there. There we go. Wiggle, wiggle, wiggle. Pop. Yeah, that's the underside of our 3.5mm input. Very good thing we took it off. Yeah, this would have caused issues. This already has caused issues. All of this black stuff is conductive black goo. So these would have, if these don't already have balance issues, they would have very quickly gotten them, because this is just dried up and terrible and falling apart. Just look at that. Awful. This is supposed to be soft. And when it turns hard, it turns into water. And then it conducts and corrodes. Ugh. Yeah, you can see how it's been corroding that of a leg. It's all green and terrible. Slurp. This doesn't need to be perfect, I think. I think that's good enough. It just needs to not conduct between the legs. The board is pretty. Yeah, how you can really see the moisture this stuff causes. If we, let's see if I can just rub it around for you. It's so hard to see, but this is completely covered in water. It's completely covered in moisture. Due to the black glue breaking down. So we need to just put some alcohol on that, it'll be fine. It hasn't had time to ruin the PCB here, thankfully. That's good enough. Back it goes. Okay, Wills asks, I had to order some caps for an Xbox One power supply. Do you have any brand and series preference for something like that? It really depends on what capacitors were there from the beginning. I usually do Nichicon or Chemicon or Panasonic are my brands of preference, and some of those like small consumer things like the Xboxes, but they have very tight specs on the caps actually. to reduce parts count, so you need to be quite careful what you choose, but Nichicon KY are usually good. PW are also usually good if you can fit them. Panasonic FR and FM series are very good, but sometimes you need to go for the ultra low ESR series, and you can find that in like the documentation. If you go, for instance, on DigiKey and look up the spec for Nichicon KY, you're going to find like that. In the beginning of the datasheet, there's a bunch of arrows where it's like KY series is that compared to some other series, which is that compared to some other series, and then you can just browse different series like that, and you just need to compare. If you can find a datasheet for the original caps, you can just compare like ESR and ripple current characteristics with the ones you're buying and work from there. That's how I usually do it, but my like general caps for everything are usually KY, PW, FM and FR series. The first two I think are Nichicon, the second are Panasonic. That's for like switch mode power supply stuff. It's usually fine. Fluffy Floofer asks, do low ESR caps hurt in applications where they're not required? Not usually, but they can. Low ESR caps, like the ones you find in switch mode power supplies, usually have a water-based electrolyte, which is completely fine, even though it sounds terrible. But it does have the downside of having a slightly higher leakage current than some other caps, like for instance audio grade caps. So if you're installing decoupling capacitors in something, if you're installing audio coupling capacitors, you don't usually want to use low ESR caps. I actually had a huge problem when I was working on my Luxman C120A preamplifier, that one uses electrolytics for decoupling, for coupling the audio signal, and I actually had to, I'll show you. I actually had to go out of my way to special order some of these gold-colored Nichicon audio caps, because the leakage current on the low ESR decoupling caps was just so high that it caused DC offsets inside the preamp, and it just would not work properly. These audio caps, let's see, they are, what series are they? These are FW series. Nichicon, I think. Yeah, Nichicon FW for audio coupling applications. But these should, of course, not be used in something like a switch mode power supply. So, your capacitors, type and brand, it matters. And not all caps work in every circumstance. You need to have a bit of a clue what you're doing. But in general, if you just shove like Panasonic FMs or FRs into everything, it's gonna be just fine. Panasonic FM, Panasonic FR, they're what I use in like high durability industrial stuff. That would be one remounted 3.5mm jack. Fuzi Allah asks, why are we not celebrating? We are celebrating New Year's, but New Year's is not for a few more hours. I want to play the 1812 Overture on these tiny speakers, you see. just completely destroy them. Right. Oh yeah, let's go back to the wide cam. I also replaced all these electrolytic caps in this with film caps. Worth doing, they were all leaking and terrible. So, I think we're all starting to get somewhere with this. I want to swap out this one capacitor that's mounted really badly. I think I have all the original crap here. So let's see what that was. 25 volts, 100 microfarads. Good. All the caps that have been replaced are 25 volts, 100 mic. I think I have a bunch of 25 volt, 100 mic. Maybe. You'll have to excuse my digging for components off camera. What's this? 120 microfarad, 16 volts. No, I have 1 million of those, and that's not right. Do I seriously not have any proper 100 microfarad, 25 volts? I think I do not have any proper 100 microfarad 25 volts. I have 35 volts, but they're way too big to fit properly. Cables sequence for HW series on the caps for his Xbox One. I don't remember HW off the top of my head. Okay, well, since you're throwing a bunch of money at me, I'll just quickly Google that for you to see if you can use those or if you can get some news. How the hell do you get a new tab on bloody new Firefox? New window. Nikon HW. Do I have screen capture? Can we do screen capture? I have had. Oh, there we go. Screen capture. So let's see if Nikon HW are useful. Oh God, do we have audio? I think we have audio still here. If these are any good for something like an Xbox. I'm seeing ESR specs. Let's just look. Yeah, this looks pretty good actually. Very high ripple currents. Yeah, what you want to look at when you do the choose your capacitors, if you just want to make sure that your impedance is, in the rough ballpark of the capacitor you're replacing or better. Usually the 20-degree spec is what you want to look at, and the ripple current as well. And once you've done it a few times with a few different brands and models, you'll just get an intuitive feel for what's a lot and what's not a lot. Like this is a 35 volt 470 microfarad cap with a 2 amp ripple current rating. That's a lot. That's a bloody lot. That's a very hardcore capacitor, I can tell you that much. So okay, well, so as long as you manage to fit these capacitors inside of your Xbox, they're going to be completely fine. they're gonna be completely fine. For CLR asks, is the cap values critical for this application? Audio stuff. So the capacitors in this thing, some of them are critical, some are not. These are coupling caps, input coupling caps. They matter. The rest of these are just power filtering. They don't really matter. Well, they do matter. You want them to be big enough, but like having too big a cap doesn't really matter. So we're going to be swapping it. No, I don't like these two stupid coupling caps up here being the terrible T-Bore brand, but I don't have any suitable caps to replace them with, so I guess they're just going to stay. They're probably fine for another while. But I do want to make this thing not be a mess that's like not well done. Not well done at all. Is there a reason why it's done like that? Not really. Like, we can probably just fit that fine. So yeah, the values always matter on a capacitor, but you just need to be aware of what sort of circuit they're installed in order to gauge how much it matters and what effects changing the value is going to have. Full T asks, how's the transistor doing? Which transistor? Why the hell was that capacitor mounted so poorly? I really don't get it. There's plenty of space. Plenty of space. What even is its job? What even is that capacitor's job? So it's hooked to between the negative rail and the resistor and something. I probably want all of these small ones to be the same, so we'll just swap them out. They're 100 mic, 25 volts or up. All the labels on the board are fine, so we can just suck them all off and swap in new parts. Some of these might be coupling caps for the audio, that's why I want them to be the same. Although I know that this one is just the power on delay capacitor, so that one does not matter. The bigger this one is, the longer it takes for the speakers to turn off and turn on. Faulty refines that he means the multi-legged thingy with a hole onto it where the cooler attaches. This is not a transistor, it's a power amplifier module, a TDA 7265. This is an integrated circuit, not a transistor. A transistor just has 3 legs. This is a bunch of different transistors. So let's see if we have any good suitable caps to put in here. I have a really old one there. Let's just take whatever. We'll just take whatever. That's fine. Regardless, the power amplifier IC has been replaced and it's working fine. I knew that this amplifier was working before I started this stream even, because I had tested it. The issue was a black goo causing the power on circuit to fail by shorting it out. That's a lot nicer looking. We'll just solder those down. These speakers are getting so much more attention than they deserve. Oh crap, I got something on this thing I needed to check. Give me a moment. Oh, there we go. What was I doing? I was doing some solder joints. Well, I had to get in my head in the way of the camera. There we go. That's our new capacitors installed. I have no idea what these are doing, but I'm happy we replaced them. Okay, Will says, thank you, but don't stop what you're doing to answer me. I was pretty sure even if I ordered the worst possible cap, it could not work in LS. Sometimes it will work just as poorly if you get the wrong caps, but those you got are just fine. And Wills, you're like, don't think I didn't see you throwing a bunch of money at me, man. I notice. I am obliged to be nice to you. Station 240 says, which is incorrect, the only problem with cheap caps is the higher likelihood of having to replace them again later. That's wrong, completely wrong. If you get capacitors that aren't low enough ESR and can't handle the ripple current, circuits in switch mode power supplies will often just not work at all. You will put in new caps and things will not improve. And you will spend an eternity trying to figure out why it's not working, and then you replace the caps again and then it starts working. You need to be very critical with your capacitors for switch mode power supplies. We might have a broken resistor here that I want to check out. It's a 47K, I think, or 4K7. Well, there's a 4K7 in it. It's still working, so it's fine. And yeah, we also want to swap out these two caps there. 470, 25. And the labels are correct, so we'll just desolder them and put a couple of new ones in there. These are straight across the power supplies, but always energized. So these are going to wear out quite quickly. I'm doing the mistake of trying to desolder lead-free solder joints without putting some leaded solder on them. That never works. There we go. Did that come off? Yes. Pop. It's not smelling leaky, but I want to swap them anyway. 470, 25, I need to fetch my box of 470s. Let's see what we have. 470, 25. 470, 16. Nope. 470, 35. This is good. A good look at what kinds of caps I like, by the way. This is Panasonic FR. We have Chemicon KY. We have, these are huge, Nichicon PM. Those are nice and high spec. There's probably some PWs in here as well somewhere. And of course the classic Panasonic FM gold label. They're beautiful, beautiful, but the FR series have actually caught up with them recently, so Panasonic FM and FR are both beautiful caps. And I think we're basically forced to put 470 35s in here because I don't have any good 25s. I don't think it's going to be 16s as well. Yeah. Okay, Will says, if you're nice to me, I'll stop giving you stuff. I liked you the way you were. Well, okay, you asshat, I'll stop then. Screw you, K-Wills, you bugger. I will not give you any further advice. Let's get these guys in there. Oh, this terrible thing. I want to get rid of this 1 microfarad 50 volts tiny thing. Yuck. They always break. Okay. These are going to be the nicest Audioengine 2s in the world. Putting more money in capacitors in than the manufacturer put in the entire board. Yeah. I do not mind handing out advice as far as which capacitors to buy, regardless, because so many people make mistakes with that. It's terrible. It's not as bad as it used to be when no one understood the point of low ESI capacitor, but it is important. And I like to spread knowledge. And the idea of someone throwing something away because they bought capacitors on eBay, just, that hurts me. Now that said, in something like this thing, it really doesn't matter much which caps you use, because it's all low frequency. Low frequency, low current. I really don't care to reinforce the traces to... Yes, I do actually. It's fun to flow solder. We make it fat. Make them traces fatter. That's fine. Give me a second. We don't need a fan. FFcossag says, do you also have a recommendation on the super cheap soldering station? I don't recommend super cheap soldering stations. I would imagine Big Clive as your go-to person for that sort of thing. I have my 10-year-old OU 2901 and it's all I ever used. It never breaks. It performs well. Oh yeah, 1 microfarad. You're going. I'm not even sure I have any 1 microfarad electrolytics. I think all of my film caps. Oh Jesus, I barely even have any 1 microfarads at all. Oops. $105, that's a 1 microfarad, isn't it? Let's verify. 1 microfarad. Good. Okay, Wills just threw $10 in the super chats. Thank you. That's not quite right either. You're not supposed to give me money for doing stuff wrong, man. I'll be your little bitch. It is 1 microfarad, right? Yes, 1 microfarad. And it's between there and there. This board is surprisingly easy to work with. Most of the solder joints I've managed to undo without even having to add any solder. Of course I failed both on this cap while I was saying that. Well, I failed 1. We'll just rip it gently. Come on. There we go. Off you come. Don't care about polarity. The new one's a film cap. There are very few times where you can't replace an electrolytic with a film cap. So I tend to just only buy film caps for my small values. It's just a better way of doing things. Ah, that's beautiful. Rose Electronics says, hello, I'm back. Hello and welcome back, Rose Electronics. We're just about getting finished up on this. Okay, so now we actually need to consider some leakage, because we do need to glue around the 3.5mm connector, because there's going to be air leakage and huffing there. And we also need to glue around here, or there's going to be huffing there. And I'm going to solder these two pins on my power switch. Just for good measure. There we go. More mechanical rigidities. Always a good thing. I get soldered, you silly thing. Did I ruin the bottom solder joints? Nah, it's fine. So now we'll just start gluing, I guess. Let's get rid of this. That's some sneaky, nasty black tar. I don't like that. It's going across several tin traces. I just want the worst of it gone. So it doesn't conduct. I think that's good enough. It's not making a huge amount of connections between different things. It doesn't really matter too much if it's just there, as long as it's not bridging points. Okay, well, says, I'm trying to soften you up so I can dump a bunch of electronic components on you. I'd rather not be soft if it's going to be raining parts, man. Electronic components are heavy and hard. Right. Do we need to clean this up anymore? Is that black goo, or is it... That's just Loctite, so we don't need to care about that. Top side is nice. It's bloody well fine. It's good enough. Now, let's just glue everything together and get it back together. Well, actually, let's do a sanity check. Let's make sure we haven't ruined it by doing all this stuff now. So let's just quickly hook it up and make sure it actually plays. So we'll get the signal and we'll get the power and we'll get everything. Where's the power? There's the power. It's off. Pop. Ouch. Does it turn off? It does turn off. This is fine. This is completely fine. We have repaired this amplifier module. Let's get messy with the black goo. This is the good stuff. We need long, thin tools for applying the white goo. Oh. So much better with a black goo. So the point of doing this is to just make the PCB more or less airtight, because this entire module is made in a rather precarious way, where it really would like to leak a lot. So we need to make sure the PCB is just one big solid chunk with no leaks on it. That also goes for the 3.5mm plug here. There are some holes there. We're just gonna make a complete mess here. Absolute mess. And each of the little white capacitors needs to get a little gob so they don't shake loose. Oh, that one really didn't need anything extra and I did it. Oh well. I don't think that's gonna fall off, so it's fine. We don't really have any more holes or big mechanical components that need securing. We do need to put a bit of mess on the capacitors. We've already made a mess. Station 240 asks, are you worried about air leaks or moisture? Air leaks. Because of how this is mounted, the PCB needs to be airtight. Or it's going to be whistling. And there are a few things more annoying than a whistling speaker that you do not want whistling. And this is a bit also to just mechanically reinforce everything. Just make sure it stays where it's supposed to. Just adding a bit of goop on large components that are standing up on the legs is a very good practice because it just kills any vibration damage right in its tracks. It will save your solder joints. Oh geez, these caps might actually be too tall. Oops. That's not good. I need to really push these caps down because they are taller than that screw by a decent margin. So that's a problem. We need some other 470s. We need some other 470s. That's probably a problem. So do excuse me while I have a component raffle off camera. Oh, and Kea, yeah, it's a couple of small speakers. Small speakers that were going to be thrown away. That I decided to save. We've been fixing them for the last hour or so. I can't really look at Discord for you too much while searching frantically for components, sorry. I can't believe I don't have any good 470 microfarad 25 volt caps. It's silly. Like basically everything I have is 35 volts and way too large. I probably have something suitable like in a big order that I've special ordered for some project at some point, but my tactic when it comes to storing like project-specific parts is I just leave them in a giant pile related to that project, so I have like 1 million DigiKey boxes like this lying around with like all the parts required for some specific machine. I think we're just gonna have to maybe lie those capacitors down. Oh no, hang on. What's this? I found a hiding spot. A hiding spot full of 470 mics of various voltages. But I still don't have any 470 25s that are actually suitable. So we're gonna have to take a couple of new 470 25s and live them on their side because these are just not going to fit in the enclosure. Oops. Where did I put the 470 microfarad box now? This has not gone well. I've lost all my 470 mics. Because of electronic components, they all look the same. Box has turned into a bag. Cadelfistro wishes everyone a Happy New Year. Happy New Year, Cadelfistro. Where the hell did I put my 470 microfarad box? So at least I think we have plenty of space to just lie them down like so. I don't think there's anything in here that's going to get in the way. No, there isn't. No, there isn't, so. Lesson learned, make sure you get the right capacitors first before you just permanently glue everything in place. Cadelfistro asks, where's the vodka? I wouldn't work on electronics while drinking vodka. Who do you think I am? Myself? No, the vodka is reserved for later tonight. I don't want to start too early. Although I suppose it is almost 9. Just a few more hours to go. Kay Wells says he lives only 30 minutes away from DigiKey's big warehouse in Minnesota. That seems like a good place to be. You just walk in there, say, hey, I want this or that, and the big robot goes and grabs it for you. I can imagine they just throw you out and say, go online and make an order, you dipshits. I can't imagine they take live customers. Out you come. There you go. Ugh, this is making such a mess. This is why you always do the glue last. And you don't screw up your component selection so things don't fit. No. feel like I'm at a Ferricon. It's just not coming off. Okay. Let's engage in proper capacitor leg bending behavior. So to bend these, you never just do so, because you can damage the seal. You always take something, put it there, and bend just ever so slightly away from the gasket. That way you have your legs sticking out slightly. You don't risk shorting against the case, and you don't risk damaging the gasket. Proper capacitor bending behavior. Beautiful. There's so much white glue everywhere. Okay, Wills asks, do you get good auroras there? Not often, because I live quite far south, actually, as far as Finland is concerned. But we do get them sometimes, and it's absolutely beautiful. I can stand an entire night just standing on my little balcony in this old house and just looking at an aurora. It's absolutely magnificent, even though they're really quite weak this far south. But you can see them clearly in the distance if you look north. It's beautiful, absolutely beautiful. Sadly though, with the last few years we've had like mostly super cloudy weather in winter. Our winter has turned into monsoon season. So visibility is usually not very good. Hi there, ZX8401, who says tight bend, the electricity will fly right off. It will always. DC will just go whoosh flying. And Kaya, if you're still watching, you should get like a YouTube account, although perhaps not. It's difficult to talk to people while doing work live on camera, if it's not like just YouTube commentary. There we go. All sorted in now. Do we need to get these properly soldered on the top side as well? I don't think so. That's fine. Well, that's completely fine. So I think this should now actually fit into the case, and oh God, we're making such a mess. Let's try and not get all the white crap on the outside. We need to use some alcohol to clean the heatsink off and apply proper thermal paste. There's enough stuff stuck on the back side to be fine. Since this heatsink is like internal, we're not going to have a big problem with thermal resistance from the IC to the heatsink. The problem is going to be from the heatsink to the air. So it's really not critical to have a good thermal interface in this application. We just bring in more of a white goo. That's fine. So there's our blobber heatsink compound. Now we also need to put some adhesive around here so it doesn't leak. Where did I put the glue? There's the glue. Generous amounts. Along every edge. Mix it with a thermal paste, that's going to make amazing results. Ah. It's all white goo anyway. There we go, I think that's going to seal decently enough. And above all, it's not going to go conductive and ruin our board again. And we definitely do not forget to connect up our speaker connector there. Snap. And now we really are, we're already making a mess. We're making a giant mess. With volume control potentiometer, it's suffered a casualty. It has seen some DC plug also got some, but that's in there. Now we can just screw everything together and there's no point trying to use any solvent to get rid of this because it just does not dissolve. You just need to mechanically rub it and scrub it. Okay. Now it's just a question of a few screws. There's glue on my screwdriver. Of course there's glue on my screwdriver. There's glue everywhere. That's screw number 1. Then we have a few special ones. There's glue on my screw. There's just glue everywhere. These just go into the heatsink, so they're not actually bolting the board down right now. Darmac asks, what glue are you using? I'm using Casco Superfix. It's very good for this sort of thing. The tube looks like that. I know that it does not turn conductive with time, and I've tested it at a really high temperature. I've actually had applications where I've just basically wrapped a solder joint in that glue and soldered it, and it's still been just fine. And that was quite a while ago in a like 3-phase application, so I had like the input connector for a 3-phase thing. It was about as wide as that, so there was 400 volts between this across this entire thing, and it was basically just made up of this glue and then soldered in place, and it's still working fine. So this glue does not turn conductive. We still have a screw for the 3.5 mil, no, not 3.5 mil, the RCA jacks there. And then we will need to see how well this is actually going to press up against the glue gasket. Making a mess. Making a complete mess of everything. Some customers would not accept this. They would just be like, no, too messy. But I'm not expecting to hand this over to any customer since it's trash. Making a mess. Okay. I think that's decent. It's definitely not sealed well around the edges, but we still need to bolt the chip down. So we still have that saving grace. The chip is isolated from the heatsink, should be noted. Somewhat uncommon for a small lamp like this. Click. That has kind of made it a bit tight, but we still need to properly smear out the glue along the edges to stop any potential leakage. Oh well, that's not just potential leakage, that's absolute leakage. Absolutely, absolute leakage. Yeah, we need to apply a lot more glue there, or it's just not gonna be tight at all. Where did I put the glue? Fluffy Floofer asks, have you ever had a rage mode Karen customer? Yes, I have. No, not for my home business, thankfully, but for a place I work sometimes. We do like take customers face to face, and sometimes there are interesting ones. Quite recently there was one that just we have a little sign in the store that says employees only, because it's full of A, customers, things, B, quarantine, because we don't want people entering and like coughing on stuff, and C, very dangerous exposed electrical wiring from stuff we're working on. And she just stormed in and was touching everything and refused to leave. But I just made her leave. It was interesting. She really wanted us to fix her stuff. Like, she really wanted her stuff fixed. But I'm not sure why she would not just be nice about it, but be like, you're gonna fix my finger, whether you want to or not, and I'm gonna break your rules and do things I'm not allowed to do on your property because you're going to serve me. Damn it. Making a mess. Okay, I think this is now ready to go back into the speaker. The bigger the gob, the better the job. You're absolutely right, Fluffy Floofer. We don't need this. We don't need these gloves. We can go bareback for the time being. If anyone's curious, we can have a quick look inside the speaker as well. They're pretty nice actually. They have this amount of damping, magnetic shielding for all your CRT needs, and they're pretty competent looking. A crossover even. 2 chokes, resistor, 2 caps. Not bad at all. I'm surprised at how well built they are on the inside, given the price point. They are cute little speakers, I can't lie. That's part of why I'm so curious about fixing them and seeing how they actually sound. Oh, that's a beautiful crotch cam right there, isn't it? I'll spare you. Just a few more screws. And then we're done. Fluffy Floofer says 4 words for credit to K-Wills. K-Wills is a decent part of the reason I'm like bothering to do streams anymore. Like, he just gave me a bunch of money and I was like, whoa man, that's a lot of money. It's not that much money, but it's still nice. And for a cheapskate hippie like me, you know, that's any money is good. As always, we're really careful not to cross-thread these, since cross-threading into MDF is a death sentence. It will never ever thread in properly again. We are so close to testing. Click. 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 That would be a complete assembly. Do we have any? There we go. That's a proper camera. So we'll just spare you my butt and wire these up for a test. hooking up the interconnect between them. Power off. Get the power cord to the external power supply. And we will get the audio signal. There should be audio coming out. Let's make sure it's unlicensed. Okay, we don't want to be playing that. I have no idea what this is. Let's just get... Wow, that's a beautiful focus. Okay, power on. Lovely. And they will turn off as well. So we're drawing 4 watts, 4 watts, 4 watts, 4 watts, 1 watt, standby. Beautiful. They will turn on. Okay. Are they leaking? Lovely. So that's actually working just fine. I don't know how much DSP and crap I have on this microphone. Let's get a song. Actually, no. Someone says the microphone isn't handling the bass well. I would imagine it's the speakers not handling the bass well, because these are tiny. I keep in mind I have smaller hands than President Trump by a lot. So yeah, tiny speakers. So that only leaves us with one final thing to do. Volume knob going on. Yeah. Okay. We are done. That's a couple of decently fixed up Audioengine 2 speakers that had failed due to bad, horrible conductive glue. So we're going to be done with that, and I'm going to try and figure out how to end this stream now. YouTube. Goodbye, everybody. I think this is how we do it. This is where it hasn't actually done it.